Alrighty, so today we're going to be looking at graphs of trigonometric functions, which are at least our two basic trigonometric functions, so that's sine and cosine. So we're just going to have a look at these two. Now, they look very similar in terms of the way they are written, and their interpretation is exactly the same. And if you remember our symmetries lessons, you know that sine and cosine are just a half turn away. Well, a half pi turn away, which is a quarter turn. So these are very similar functions, they just start at different places. So just as a reminder, because of the way that sine behaves, sine starts in the middle and oscillates up and down, whereas cosine starts at the top but still oscillates up and down. Exactly the same shape, they just start at different places. Cosine starts left of sine, or you can think of sine starting to the right of cosine. They've just been shifted. Same shape, just been translated left and right. So let's just talk through all of these different values. So we have the A, the B, the C, and the D. Let's quickly talk through them. So I'm going to do these as the cosine function, but obviously it's all the same for the sine function. It just changes the way it starts. So let's start off with some axes, and let's draw in some piece of information. The first line is the D line, which we would call the median. And the median tells us this middle line in which everything's measured off. The next thing is going to be the max and the min, which are determined by the A value, plus or minus the A value. So plus A is going to take you up, and minus A is going to take you down to the min line. And we can call this the min and the max. And they're both based off D. So the max is D plus A, the min is D minus A. Alrighty, so that's just the basic in terms of getting our shape right. For a cosine function, it's going to look something like this, to a rough extent, right? Because it starts at the max, goes to the min, goes to the max, goes to the min. And this happens, and it repeats every period. So this next bit is to do with the period. And the period of the function is just how long it takes to repeat. So you'll notice that it takes this distance here, let's call it the period, is between top to top, but it could have also been between min and min, right? It doesn't actually matter because it's all symmetric. Alternatively, we have this median point here and this median point here, and they are also one period apart. And once again, from this median point and this median point, they will also be one median apart. And so you can kind of see that this period idea is reflected in a lot of the different points that we can deal with. How do we work out the period? Well, the period's entirely controlled by this B value here. So the period is equal to 2 pi over the absolute value of B. Now, the reason we're talking about absolute value is that I don't want to worry about reflections and such, and I don't want to think of having a negative period. That doesn't make too much sense. Instead, we're just going to think of B as the absolute value of it instead. So the period is defined by 2 pi over B. Alternatively, if you know what the period of the function is, you can go backwards and work out what the B value should be. The last one is the most interesting of our different values here. So minus C is a phase shift. So the proper name for it is a phase shift. But how we would describe it is as a horizontal translation, meaning it is how we shift the function to the left or to the right. And however many units you shift it by, that's how many movements it moves. So if you want to shift it 16 units to the right, you would make C equal to 16. If you wanted to shift it to 3 units to the left, you would put minus 3 as your C value. Alrighty, so that is the cos function. It's also the sine function. Let's do some analysis. Alrighty, so let's just have a think about this function, 5 cos of 3x. So amplitude A is equal to 5. The period is based on that 3, so it's going to be 2 pi over 3. So 2 pi on 3. And there's no median value, right? There's no d value. So that means the d value is actually 0. So if I wanted to sketch this function, I start with my median line, which is 0. And then I go up 5 to find my max line. I go down 5 to find my min line. And then all I've got to do is know the shape of a cos function. And cos starts at the top. Then it goes to the middle. Then it goes to the bottom. Then it goes to the middle. Then it goes to the top. And the question is, how far along am I on the x-axis when I reach this second top? What's the x-coordinate here? Well, it's based off the period. So it's going to be at 2 pi on 3. Because that's what the period means. However, now I run into a new problem, which is that, well, I now know when the next maximum happens, because the first one happens at 0. How can I work out what these points are? These two median points and this minimum point. Well, the minimum is halfway between the maximum, so it's just halfway between 0 and 2 pi on 3. Well, that would be 2 pi on 6, or just pi on 3. Half of 2/3 is 1/3. And these other two, well, the next one's going to be halfway between 0 and pi on 3, so that would be pi on 6. More interesting one is this point here. When does this one happen? So it's going to be halfway between pi on 3 and 2 pi on 3. So pi on 3 plus 2 pi on 3 divided by 2. 3 pi on 3 on 2. The 3's cancel, so we're left with pi on 2. And that's exactly where it happens. Oh, sorry, pi on 3. Alrighty, so there you can see a quick sketch of one period of this cos function. Let's do a sine function next. Alrighty, so let's look at this one as well. So, first thing to notice is the amplitude is 6. We've got a median value this time, which is our d value, which is -3. That's going to be our starting line. And we've got a period which has been changed. It's going to be 2 pi over the absolute value of pi, because that's my b value there, which is just 2. So the period's going to be 2. So now I can go and sketch it. You can see there's no phase shift, so it's not a terribly tricky one. So first of all, draw in our median line. Our median line is going to be -3. I might just move my x-axis up a little bit. So there's my median line. That's that -3. The amplitude 6, so 6 above -3, that's going to be my maximum. My maximum is going to be at 3. And my minimum is going to be 6 below -3, which is -9. So I might just extend out this line a little bit further. Maybe a little bit too far. Something like this. There you go. -9. Alrighty. So now I just need to think about the shape of the sine function, because it hasn't been shifted left or right, so it's just a basic shape and it's not been reflected. So it's going to start in the middle, go to the top, go to the middle, go to the bottom, go to the middle, go to the top, etc., etc. Okay? And then the interesting part is, when does each of these things happen? And we'll do a dot to dot. So up, down, down, up, and up. There you go. So there's our beautiful little shape there. So the period of this function is 2, which means that it repeats after 2 units. So if that's 0, this point over here must be 2. Halfway between 0 and 2 is 1. Halfway between 0 and 1 is a half. Halfway between 1 and 2 is 3 halves, or 1.5. Alrighty, and so there would be my sketch of a cosine function. I will see you in the next one where we'll be looking at a few more interesting ones. Bye.